Graphical processing units are the most important parts of our computer technology these days. People compare it with the CPUs, but both of these are entirely different things. One is a plane, while other is a container ship. CPUs are versatile. They can depart and land at any station in the world. They can carry passengers, cargoes, and goods. On the other side, GPUs can carry loads and loads of containers, but can only travel from port to port. CPUs can do a wide variety of tasks and different types of calculations, but GPUs are very specific about the types of work they do. They are specifically made for linear algebraic calculations. There are three types of cores in the microchip of GPU: CUDA cores, tensor cores, and ray tracing cores. These CUDA cores perform straight A into B plus C calculations. The tensor cores perform matrix calculations, and RT cores do ray tracing calculations. After the microchip, the most important part of the GPU is its memory, also known as VRAM. This VRAM memory is very fast. To know the true scale, know that maximum bandwidth of your CPU's RAM is 64 gigabytes per second, whereas maximum bandwidth of a VRAM is more than 1 terabyte per second. VRAM is a lot faster than our normal memories. Other than that, these components are voltage regulators. These take the 12-volt input and regulate the voltage into 1.1 volts and supplies hundreds of watts of power to the GPU. All of this electricity generates a ton of heat on the chip. To regulate the temperature of chip, large heatsink is used, which is cooled by these cooling fans. Most of the size of a graphics card is because of the heatsink. While CPUs are used to do diverse things like running operating system, softwares, and perform general operations, GPUs are the raw powerhouse, raw graphical processing power. It's like raw strength brute force. These are used for multiple processes like rendering games, 3D rendering, and Bitcoin mining. The cores in the GPU work parallel to each other. Parallel processing makes the work very fast. A GPU performs not hundreds of million, not billions, but trillions of calculations per second. A mid-range GPU performs 36 trillion calculations per second. A GPU can perform one calculation per core in one clock cycle. The clock speed is the number of cycles a GPU can clock in 1 second. All of this results in GPU being super powerful for specific tasks, like performing algorithms like SHA-256 for mining bitcoins, and rendering frames for high graphic games that require lots of processing power and much more. There are many companies in the market that make GPUs of all ranges, but the biggest distributors are NVIDIA and AMD. GPUs and CPUs are both two different pieces of the same puzzle. They should not be compared. One is a fork and the other is a spoon. Both of them work best when they are working together, helping each other. But remember, folks, every ending is a new beginning, so stay tuned.